The Elton Mayo Building, EMB, is located in the University of South Australia's City East campus in the CBD of Adelaide. The EMB has 6 levels, 4 of which are currently functioning as a segmented office space, with a basement and plant room. The EMB is situated adjacent to the Hawke Building and linked to the Roland Rees Building. The key focus of this report is to structure a sustainable retrofit proposal of the EMB using the Green Building Council of Australia's Green Star Interiors rating tool as the framework. Having prepared a baseline assessment of the EMB's environmental performance together with the DAP Star report, the team has established a standard from which to operate the Green Star credit functions. These credits are categorized in the Green Star arrangement, enabling us to logically assess retrofitting systems and methods of improving the environmental performance of the EMB. Each Green Star credit contains criterion against which points are awarded for the proposal's delivery of the prescriptive and percentage-based requirements. Section 2 of this report, through the method and discussion of each credit criterion, considers how this proposal intends to comply with the Green Star criterion requirements. Discussion sections consider the baseline veracity and conceptualize the retrofit proposal to be undertaken. Management Credit 2.0 Environmental Performance Targets. The following table 2.1.1.2 indicates Elton Mayo Building's baseline performance and highlight the retrofit criteria and target credits within the following categories: indoor environmental quality, energy, water management. Credit 6.0 Construction environment management. A project-specific environmental management plan will be established which outlines strategies to minimize and provide framework for the following: air pollution, site operations, PPE requirements, loading and unloading to be organized and localized, dust-creating activities to require JSAs, job safety analysis, noise and vibration pollution, the development of construction methodology, selection of plant and equipment, limiting noise and vibration activities, implementing the use of hoarding and acoustic screening, waste management, the development of a site waste management plan. The SWMP will previse the waste management hierarchy. Indoor environmental quality. Credit 8.3 Exhaust or elimination of pollutants. Current printing and photocopying equipment will be retrofitted or replaced to be compliant with ECMA 328 standard. Network will be upgraded to accommodate a central printing and photocopying terminal for each level. When purchasing new equipment, a sustainable IT purchasing guide developed by HP will be followed. Indoor environmental quality. Credit 11.0 Glare reduction. Eastern windows are most affected by glare in the morning. Western windows are most affected by glare in the afternoon. Vertical blinds are a cheap option to aid in reducing glare. However, fixed roller blinds also aid in occupant security and privacy as they act in the same manner as window tints. They are able to be seen out from the inside but black out view into the room. Indoor environmental quality. Credit 14B Amenity space. A number of features are to be implemented to improve the indoor amenity space. These are as follows: installation of fly screens onto the windows to enable natural airflow and ventilation, installation of blinds to regulate daylight and reduce glare where possible. Internal walls are to be removed to create an open workspace and promote social interaction. Energy. Credit 16A Greenhouse gas emissions. Steps will be taken to reduce the Elton Mayo Building's energy consumption and greenhouse gas emissions. These are as follows: replace all existing lighting with LED lights. Install a PV solar system. Install a solar hot water system to reduce natural gas reliance. Install energy-efficient IT equipment, appliance and equipment. Water. Credit 18B Potable water. Prescriptive pathway. In order to increase the Elton Mayo Building's water efficiency, a number of methods are able to be implemented which are as follows: All fixtures within the building will be replaced with 5-star WELS-rated fixtures. Rainwater tanks will be installed for use for non-potable purposes. Materials Credit 19. Life Cycle Assessment. A number of baseline materials used within the original construction of the Elton Mayo building are: steel frame construction, standard concrete, fluorescent lighting. Alternate materials are able to be introduced to reduce the building's environmental impact, such as LED lighting. LEDs use substantially less energy. LED lights last much. Use recycled gyprock products where possible. The DEWNR case study was able to employ this method with great success. Alternate materials are able to be introduced to reduce the building's environmental impact, such as timber where possible. Timber products are able to store up to 15 times the amount of carbon. Timber products also have a very low embodied energy. Materials Credit 22A. Construction waste and demolition. Using figures from the below summary table, it can be assumed that the total kilograms of waste generated in the proposed Elton Mayo fit-out is 5,713 kilograms. It can be assumed that the total kilograms of generated waste that was recycled by the waste contractor is 5,122 kilograms. Therefore, the estimated weight of waste sent to landfill is 591 kilograms. Sustainable Sites Credit 23.3. Hazardous material. Operating federal legislation, how to manage and control asbestos in the workplace. The management team will develop a site-specific asbestos management plan. This will clearly identify the presence and location of asbestos. Furthermore, it will outline the control measures to be implemented when removing, enclosing, encapsulating and disposing the asbestos. This report operated the Green Star Interiors framework against the baseline environmental performance of the Elton Mayo Building, EMB. Using the established baseline, the report identifies the Green Star credits to be targeted. Each group member was specified credits, of which each would provide method and discussion analysis. Group members then integrated their piece into the final report. Communication and collaboration were the keys to understanding each other's components. Given the amalgamated nature of the Green Star credits, we found that the EMB needed significant retrofitting to satisfy the Green Star criterion. Often the economic feasibility strategies employed would be somewhat ambiguous. However, the report has succeeded in methodically preparing the scope and method to undertake to sustainably retrofit the Elton Mayo Building.